Let us now look at how we would solve a typical synthesis problem through the combination of the several reactions we've already seen. For example, a question that could be reasonably asked is how would you synthesize this ether from simple starting materials such as methane and isobutane. To approach this problem, the first thing that we need to see is what class of compounds this molecule belongs to, and this is an ether. And then we need to ask ourselves, do we know any reactions that make ethers? And indeed, the answer to that would be yes. We do know SN1 reactions or SN2 reactions. Both of them can make ether by substituting something, something that's a good leaving group with an alkoxy group. So in order to get an ether by either of the two reactions, we could use this combination where we have a leaving group on a tertiary carbon and a methanol. And this would be an SN1 reaction, which would give us our desired product. This reaction will work just fine. Leaving groups can be things like chlorine or bromine or iodine. And will work just fine because we have a tertiary substrate, if we have a weak nucleophile, there is no possibility for meaningful rearrangement, so all the conditions for SN1 reaction are there. Alternatively, we could have our oxygen be parked on the tertiary substrate and our leaving group be on the methyl position. In this case, this would proceed through an SN2 mechanism because our T-butoxide is a strong nucleophile. Even though it's bulky, that is fine in this case because this is just a methyl group, so there is no possibility for elimination. So there is only the substitution is the only choice. And so this should work as well, again with similar leaving groups such as chlorine, bromine, or iodine. However, the problem now is that we are asked to make these compounds from the final compound from methane and isobutane, and we didn't get there. And so we need to simplify our starting materials even further. We need to get to an alkane. And we could do this in either of the two cases, but let us first let us consider this route just for the sake of simplicity and see how we would make these compounds from simple alkanes. This material can already, as we said, be a halide, so this could be a bromide, chloride, or iodide. And one thing that we've seen a lot is that we can make these halides, actually bromides and chlorides, by radical halogenation of alkanes. And in this case, we could make the tertiary bromide quite easily by brominating isobutane in the presence of bromine and light to get here, because the tertiary hydrogen is replaced preferentially to give bromine. And this should work quite well. So this explains how we would get this substrate. But to get to methanol, again, we ask ourselves what reactions do we know that make alcohol? Well, at this point we know only one, and this is the SN1 substitution. This is actually the SN2 substitution. This is probably the first SN2 substitution we've ever seen, where we take methyl bromide, replace it with hydroxide to get an alcohol. And so this is how we could get methanol. And methyl bromide, again, we would make from bromine and H nu starting with methane. And this now allows us to create methane in this step and this here. Both of them undergo into SN1 reaction and give us a desired product. So in order to streamline these synthesis problems, the first thing that you need to do is to start thinking backwards. That you look at the material and then you ask yourself, what class of compound is this? What reactions do I know that make that class of compound? Then devise a substantial, meaningful reaction of that type, and then look at your substrates for that reaction and see whether those substrates are the ones that the problem asked you for, or whether they're different. If they're different, then you need to repeat this iteration once again and see what substrates could you make these new substrates from until you get to your desired size. It's also important to understand that if you're asked to answer a synthesis question, you should not supply mechanisms. But you cannot propose a meaningful synthesis without very thorough understanding of mechanisms, and that will be the subject of our next practice problem.